Start.
Welcome to this video. Here we are going to see about flow through Venturimeter. As we already know about oricimeter, there is no difference between Venturimeter and oricimeter. The only difference is you can see in the oricimeter there is only a small opening through which the pressure and pressure will be flow. But here we have a throat which will be in a divergent condition, which help the water to flow in a high rate, which we can say as the time taken to the water flow in Venturimeter compared to oricimeter is less. It will flow easily because of this throat expansion. Okay, it is here also we need a same procedure as oricimeter. Here we consist YouTube manometer and again inlet wall, open outlet wall and Venturimeter. This is called Venturimeter with a throat or divergent throats. As we done in oricimeter, then also we have to level the mercury level in YouTube manometer, for which we can use this to valve open it simultaneously for the leveling. We can either use these two valves or these two valves for leveling purpose. After leveling, we can start our experiment to take the value readings. First, after you leveling the YouTube manometer, first we are going to open this outlet valve. After opening the outlet valve, the water will be flow through this pipe and it will be collected in a collecting tank, which is again its area also same as the oricimeter, which is 40 by 40 centimeter. And then first we have to note down the head values here. Here also it is a similar head values. From your left side you can note down as a H1 value. For right side it is a H2 value. And the difference between them is the head difference will be differ from oricimeter because it contains that throat and the pressure level will be helpful for water flow easily. So the head difference will be get reduces from oricimeter, and then again we can take that time taken for 10 centimeter for the rise, and the rise time also will be reduced compared to your oricimeter. After this calculation, we have to take at least 4 readings for the efficiency to identify the efficiency purpose. Further, we can see it in the calculation part.
For the calculation part of Venturimeter experiment, we are going to identify the coefficient of discharge through Venturimeter. For this discharge, we have to identify the actual discharge and theoretical discharge through Venturimeter. For actual discharge, the formula is Q actual, which is equal to A into R divided by 3. A is the area of collecting tank and R is the height of collected water in the tank, which is 10 centimeter, and T is time taken for 10 centimeter rise of water. And for a theoretical discharge, theoretical is equal to K into root of H. For the calculation of K is equal to A1 into A2 root of 2G divided by root of A1 square minus A2 square. A1 is area of inlet pipe and A2 is area of the throat through which the flow is carried out, and G is specific gravity in meter per second square. For H calculation, we are going to use the formula as H1 minus H2. This we can get from a different level in YouTube manometer, and SM divided by SW. For SM indicates the specific gravity of mercury which is present in your YouTube manometer, and SW is the specific gravity of water. After calculating this theoretical value and actual value for each reading we took, we can identify the coefficient of discharge by using the formula CD is equal to Q actual divided by Q theoretical. From This we can identify the coefficient of discharge, and by taking the average of those all readings, we can finalize the coefficient of discharge through Venturimeter. Thank you.